Good morning. My name is Jibin and today Brian Valentine and myself would like to talk to you about health, safety, and the environment. Just a quick outline of what we're going to talk about. First, we're going to cover the introduction, then risk assessment, regulations and agencies, fire and explosion, pressure relief systems, process hazard analysis, chemical safety and hazard investigation board, then inherently safe design, and then finally a conclusion. Just a little introduction into health, safety, and environment, how chemical engineering is directly related to that. If you look at the health industry, chemical engineering is related to pharmaceuticals and how we all pharmaceuticals relate to health. And then safety, chemical engineering designs shatterproof polymer glass. In environment, they make catalytic converters, which affect the environment too. And in order to maintain health, safety, and environment in the industry, government passed a couple of regulations, and for the employees there's OSHA, for non-employees and the environment there's NIOSH or NIO as such, and transportation there's DOT, and energy there's the DOE. And first we're going to talk about risk assessment and covering voluntary and involuntary exposures. In our day-to-day life, we are basically exposed to voluntary and involuntary risk compared to whether it be deciding to smoke cigarettes. That's considered a voluntary risk in the book, and I guess I could be twisted either way, but also involuntary exposure is a risk that you're forced to. And that's what most of the agencies here are trying to avoid. It's an involuntary exposure at work. And as far as statistics to help you make a decision on risk assessment, there's a few. OSHA has an incidence rate, which is basically the number of injuries or illnesses for every 200,000 hours of exposure. There's also a fatal accident rate, which is the number of fatalities for every 100 million exposed hours. And then there's a fatality rate, which is the number of fatalities per year divided by the total population at risk. And comparatively, chemical process industries are safer because they actually employ a lot of remote sensing and operation. And in general, people are concerned about chemicals and they're more safe around it. They would like to know what they're handling. And also, engineers try to make the plant safer. And this is a table pulled from our text. It basically covers the three statistic categories that we talked about. And if you look at the numbers, chemical industry actually has one of the lower rates, and even staying at home can be fatal, which has about 3 listed in there. And those are just some of the activities listed on the book. There's more that could be found on the websites. Moving on to the other part of risk assessment is where you have to do worst case scenarios, and this is where you imagine the worst possible consequence. And this is used to help avoid serious injuries. And also the size of the area affected by an accident should be covered way before it happens. And this is somewhat hard to develop because you have to figure out when you're being random and when you're actually sticking with something that could happen. Because in the book there's an example of a comet coming out of the sky and hitting a nuclear plant and blowing up the whole place. And now, how would you protect yourself from that? Well, you still have to think about it. That's what they're trying to get you to do. It's just the remote possibilities you have to be ready for, even though kind of like expect the unexpected. But there's some guidelines listed on EPA and OSHA. And as far as the role of chemical engineer in health, safety, and environment, the chemical engineer is expected to know what's going to happen. They're the ones with the best knowledge of the process, so they have to think about the safety of the employees that it's going to affect, and it's their responsibility to communicate with all of them. And moving on to the regulations and agencies, there's non-governmental agencies such as AICHE, which is also involved in making those regulations. And all these regulations are listed under the Federal Register and also published under the Code of Federal Regulations. And talking about OSHA, which was established in 1970, there's a general duty clause, which is place of employment it's basically for the employers to offer a place of employment free from hazards. And they also have an integrated risk information system, IRIS, where you can look up the hazards for chemicals used in your industry. And there's permissible exposure limits, which is based on a 40 hours per week assumption, and time-weighted average, which is based on an 8-hour-a-day shift. And also, if you have to use something that's hazardous, and if it's more than the permissible exposure limit, then you can have a short-term exposure limit, which is based on a 15-minute time-weighted average. And then there's also the immediately dangerous to life and health category, which you have to have respirators or other equipment to keep you alive. And they also established the HAZCOM, which is a Hazard Communication Standard. It's basically the workers' right to know what they're working with. And the employer is responsible for training all the employees. And the neat thing is, it's not that the information is just given to the employer and he just passes it on. It's up to the employer to research and find out what else is there that he could do to make the place safer. And part of that is having a MSDS, the Material Safety Data Sheet, and which basically lists the material manufacturer, hazardous ingredients, physical chemical characteristics, fire and explosion hazard data, reactivity data, health hazard data, safe handling and use and control. And if you look in a lab in our school itself, you can find an MSDS printed, and which basically lists all of these in there. And also there's a process safety management of highly hazardous chemicals, how to go about handling hazardous chemicals. And first step is employee participation. While we were in Arizona, the first thing we did at every meeting was to have a safety share, which is basically employees coming up and talking about safety. And it also instilled that safety first attitude over there. And part of it was talking about different safety aspects of just living in Arizona too. One guy came up one day and talked about when he put on his boot, he actually shook it, and a scorpion walked right out of there. And that was a good heads up to check my boots every day before I went to work. And just random stuff like that that you never know until you hear it from other people. And then there's process safety information, where the employers have to research the material, process hazard analysis, and operating procedures have to be listed for the employees. They have to know what the startups, shutdown procedures are, and also if there's an emergency, how to go about it. And contractors, they're also covered. They have to be trained by the employer. And pre-startup safety review, which has to be done before a plant is started up. Mechanical integrity is where the equipment is checked on a daily basis just to make sure that it's working properly and not harming anybody. And so that way the workers are well informed if there's a flaw in the system. And also a hot work permit is where if someone's working with fire and sparks, then somebody working with flammable chemicals should know that he shouldn't be working right next to him. And management of change is where basically if people make changes to an equipment that's not manufacturer installed, then they need to let everybody else know who's using it so they're not in for a surprise. And incident investigation is basically making reports to show what happened so it doesn't happen again. And emergency planning and response, and finally compliance safety audit, which is basically helping everybody be on the same page in a sense of safety. And now to talk about EPA, I'd like to introduce Brian Heflin.